Here in section 2.9, we're going to take a look at inverse functions. So in order to do that, we have to back up and talk about what one-to-one functions are. So we're going to discuss one-to-one functions. All right, so a function, now remember, before we start that, remember that a function said that you have to have only one output for every input. But it did allow for different inputs to go to the same output. Now let's see about this. So a one-to-one function is a function is one-to-one if no two members of the domain have the same image. So no two inputs can go to the same output. Another way we have of saying that is that if fx1 equals fx2, then x1 has to be equal to x2. In other words, if two outputs are the same, they must have come from the same input. So what would this look like? Well, if you had something like a bunch of inputs in here and a bunch of outputs over here, and you went like this, and this, and this, so this function f here would be one-to-one. Just as it says, 1 in the domain goes to 1 in the range. Now something like this is still a function, but it is not one-to-one because we have these two inputs going to one output there. Okay, so graphically we can see it in this illustration, but when we try and get into specific functions, how do we decide if a function is one-to-one? Well, one way is to look at a function's graph. Okay, when we were looking at functions before, we talked about the vertical line test to decide whether something was a function or not. Now we're going to look at the horizontal line test. So if we already have a function, then we can look at a horizontal line test to decide if we have a one-to-one function. All right, so let's say, so what are we going to do? If a function f is one-to-one, then no horizontal line intersects the graph of f more than once. Okay, so let's look at something like this. So here's a nice function here passing the vertical line test. And now I'm going to do horizontal lines. Okay, so if I do some horizontal lines here, whoops, sorry. We see that each time I intersect the function only once. It is one-to-one. Over here, let's do something like take this. Perfectly good function according to the vertical line test. Now when we start doing horizontal lines, first I don't intersect it at all. Then there's one place where I intersect it once. So far so good. But then we start seeing that, of course, as soon as we get there, we start intersecting twice. And for this reason, this function is not one-to-one. You can also see that by the fact that, thinking of it this way, the outputs, so the output that you got here and the output that you got here are coming from two different x values. The one x value there and the one x value there. Hence, we have two inputs going to the same output. That's not what we want from a one-to-one. All right, so knowing that, let's try and describe what we mean by inverse functions. First, think of two functions. Let's take f of x equals x cubed, and g of x is the cube root of x. Take some values. Notice that f of 2 cubed is 8. Okay. And yet g of 8 is the cube root of 8, and you get 2. F of 3 cubed is 27. G of 27, cube root of 27, is 3. F of negative 4, you get negative 64, and g of negative 64 is negative 4. So what we're seeing is that if we have f of a is b, in other words, f takes a to b, then g takes b back to a. This makes these two inverse functions. So when you take something and put it into f, you get a certain output. If you take that output and make that the input into g, then you get back what you started with in the very beginning. So let's get a nice definition here and see what we can say. Let f be a one-to-one function. Then the inverse function of f is the function g, whose rule is g of y equals x whenever f of x equals y. All right, that's saying that if we have some x here in the domain of f, and it gets sent by f to some y in the range of f. Okay, so what we're saying is if f takes it over like that, then g would be the function that takes it back. So interestingly enough, we see the domain of g is the range of f, and the range of g is the domain of f. So this switches around now. This, we're starting over here now when we're talking about g, and this is the domain of g, and it goes over here, giving us this is the range of g. Okay, so f takes it one way, g takes it back the other. Now, notationally, this is some unfortunate notation. So if we have the function f and we want to talk about its inverse, we give it this notation, f inverse of x. So this this negative 1 here, this is not an exponent. Right? It is simply saying inverse. That's the inverse of f. So whenever you see that, that is not a power, it is not an exponent, that is simply saying the inverse of x, and it's read f inverse. Okay, so obviously we need to know how to actually get these inverses. So before we had x cubed and the cube root of x, which kind of makes sense. We're looking for inverses to undo each other. So when you're talking about a function f that does something, f inverse undoes it, and it works back and forth. So what we're going to try and do here is figure out how we should do that algebraically. How do we start with a function and figure out its inverse?